Everyone, and welcome to my channel Computer Classes by Rachna. Before I start with what is a threaded binary tree, you all should know what is a binary tree and different types of binary trees. So for that you have to check out my previous videos. Now we are talking about a binary tree which could be threaded. So this is an example of a binary tree where root is at A and it has left and right children as B and C. B has a left child as D and a right child as E. C has a left child as F and a right child as G. So this is a normal binary tree. We use threaded binary tree so that we do not have the null representations. Whenever there is no left child and right child, we use null for that. So when we do not want the null to be used, we can have a threaded binary tree which will point to a node in the tree itself rather than a null pointer. So we can have two types of threaded binary trees. One is left threaded, another is right threaded, and these are the basic. Then we have the combined type which is called as complete threaded binary tree, which have the left threaded tree as well as the right threaded tree. So without wasting time, I will discuss what is a threaded binary tree here. For getting to know a threaded binary tree, we should have the in-order traversal of the tree. So I will write the in-order traversal of this tree. So what would be the in-order traversal of this tree? We will have the in-order traversal as the left, root and right for every node. So I'll tell you the shortcut for the in-order traversal. We move to the extreme left of the tree starting with the root. So we move to the extreme left. What is the extreme left of the tree? The extreme left of the tree is D. So D, and then we move inward, we have B, then we move to E, then we have A, C. We will not take C because we move to the left child first. So F, C and then G. So the in-order traversal of this tree is D, B, D, B, E, A, F, C and G. I will write down the in-order traversal again. The in-order traversal of this tree is D. Why D? Because we have the root. We have to first go to the left. Again, here we have to first go to the left. So this is the extreme left. So we have root's left child, which is this. Left, root and right. The root should be in between. So we have the left, which is D. We have its root, which is B, and we have its right, which is E. Now the left child is completed in order. Now we move to the root. So the final root of the tree is A. So A, left is traveled. Then we have traveled root. Now we will travel the right child, which is C, also in order. So to travel C in order, we should have F, then C and then G. So F, C, G. So I have told you both the methods, the traditional method and a shortcut method to the in order of the tree. Now, first of all, again, the in order is D because it's the extreme left child. So we will go for D, B, E, A, F, C, G. D, B, E, A, F, C and G. It is very important to get the in order because only then we can do the threading. Now for left threading, we have to replace the left child, which is null. And with what we should replace? We should replace with the predecessor in the in order. For example, if I talk about G, the predecessor of G is C. If I talk about F, the predecessor of F is A. If I talk about E, the predecessor of E is B. Alright. If I talk about D, there is no predecessor of D. So the left child of D will remain as it is because there is no in order predecessor of D. But rest have the predecessor. So we will replace all the left child which are null with the predecessors. For example, the left child of G. So it should point to C. The left child of F, it should point to A. We can use dotted lines to represent thread. That's a better way. Alright, so instead of this arrow, we can use dotted lines to show that it is a thread. Then to represent the left child of E, it will point to B because it's the in order predecessor. So you can see all the left children of the nodes E, F and G are pointed to by the threads. So this is until now it's an example of a left threaded tree. Alright, this is an example of a left threaded tree. Now we will create an example of a right threaded tree. This is an example of a left threaded tree where all the left null child are replaced by threads, but the leftmost node does not have the left null child. The leftmost node is not pointed to by the thread. It will be null. Alright, similarly in the right threaded tree, the rightmost child will be null. We will see it again. So this is the left threaded tree. Have you noted? Now we will make the right threaded tree out of the same tree. So again, I am writing the in order first. What is the in order? The in order of this tree is D, B, E, A, F, C and G. This is the in order. Now we are talking about replacing the right child which is null. So this will point to the successor in order. So first of all, see which nodes have the right child null. D, E, F and G. Alright. So first of all, let's see D. What is the right successor? What is the successor, in order successor of D? The in order successor of D is B. What is the in order successor of E? The in order successor of E is A. What is the in order successor of F? The in order successor of F is C, the one which is at the right side in order. The in order successor of G, there is no in order successor of G because it is the last child at the right side. So the G null at the right child will not be replaced. Rest all will be replaced by their in order successor. All the right null childs will be replaced by their in order successor. So right of E will be pointed to A. The right of F, this null will be replaced and it will be pointed to C. Whereas right of G will not be replaced. It will remain as it is. So this one is an example of right threaded binary tree. So this one is an example of a right threaded binary tree. Alright. Now we are talking about this right threaded or the left threaded. They are called as one-way threaded tree. So this is one-way threading. One-way threading means that we are replacing either the right child which are null or the left child which are null. So if we replace the left null child, they will be replaced by the in order predecessors. If we replace the right null child, they will be replaced by the in order successors. Is this point clear? So this is one-way threading. Now we also have two-way threading. So what is there in a two-way threading? In the two-way threading, the same tree is shown, and in this we will be adding both. We will be adding the right threads also and the left threads also. So this is the in order which is given. The in order that is given is the same D, B, E, A, F, C, G. And now we have shown the left child as the green color, left threads as the green color, and the right threads in the red color. So can you see? So we have applied both right threading as well as left threading. So for right successor, D should point to B, right child of E should point to A, and the right child of F should point to C, and the right child of G should be blank. It should be null. So this is fine. And you can see F is pointing to C, you can see E is pointing to A, and you can see D is pointing to B. Look at the red colored threads. All right. Now we talk about the left. Now we talk about the left child. So for the left child, I'm using this green color, that G left should point to its predecessor, which is C, and then the left child of F should point to the predecessor, which is A, and the left child of E should point to B, and D do not have a left child, left predecessor. So this would remain as it is, and rest you can see all the green threads. E is pointing to B, the left of F is pointing to A, the left of G is pointing to C. So this is a two-way threading where we have replaced both the threads, both the null values with threads. The left child which were null are replaced with the green threads, and the right child which were null are replaced by the red threads. And the thing to be noted is the left child and the right child of these nodes are null. They are not pointing to anything. They are not pointed to by the threads for D and G, because G is the extreme right of the tree and D is the extreme left of the tree. So the left child of the extreme left of the tree, if it is null, it will not be replaced. And if the right child of the extreme right of the tree, if it is null, it will not be replaced. This is two-way threading with the binary tree, and all the threads are replaced except from the extreme left child of the extreme left node and right child of the extreme right node. If we want these also to be there, to be pointed to by thread, we have another option which is called as headed or header threaded binary tree. In a header threaded binary tree, this same tree would be there, but it will be replaced by the head. This head would point to the root, and the left child of D would point to head, and the right child of G would point to the head. So this is the headed So this is another example of a headed binary tree, threaded binary tree with a header node. So you can see here we have the in order. First of all, I'll give the in order again. The in order of this tree is D, B, E, G, A, C, F. All right, this is the in order traversal of this tree. D, B, E, G, A, C, F. Now we see first of all the right threading. So I'll mark the right threading. The right thread of D is blank. The right thread of G is blank, which is null. The right thread of F is blank, which is null. And these are the nodes to which we do not have the right child. D does not have a right child, G does not have a right child, and F does not have a right child. So we will mark the nodes with blue color. So the right of D will point to its in order successor, which is B. The right of G will point to A, and the right of F, we do not have the right of F here, so it would not point to anything if it was a normal two-way threaded binary tree. But since it is a binary tree along with header, it is a threaded binary tree along with header, the right of F would go to the header node. So right of F would point to the header node. So this is going to the header, done. And the right of G is going to A, and the right of D is going to B. So the blue ones are my right threads. Can you see that? Right null threads which are replaced now. Now I talk about the left children. So the left of D is null, and the left of E is null, the left of G is null, the left of C is null, the left of S is null. So they should point to their in order predecessor. So D should point to nothing, but since it is a header node binary tree which is threaded, so it would point to header. And the left of E should point to B, the left of G should point to E, the left of C should point to A, and the left of F should point to C. I've marked this in pink color. So first of all, let's go with D. D should point to the header node. This is done. And E should point to the B. So done. And G should point, the left child of G should point to E, done. The left of C should point to A, done. And the left of F should point to C. So all the pink ones are the left threads and all the blue ones are the right threads. And what should the node point to? The header node should point to A. So for that we have the header node pointing to A. One way is just direct connection of this with A, or what we can do, this node's left child should point to the root which is A, and the right child of this node should point to the node itself, the header node itself. So this is also another example of a two-way threaded binary tree with the header nodes. Can you see that? So this is a two-way threaded binary tree with the header node. Now we will do another example. So for that, let's say this. So we have this tree A, B, D, E, H, I, C, F, G, J. We need to have this into converted threaded binary tree. To get the threaded binary tree, we should have the in order traversal. I'm doing the shortcut right now. We start with the extreme left. So H, D, I, B, E, A, and now the nodes which have the right child, we take the right child first. So F, then J, then C, and then G. So H, D, I, B, E, A, F, J, C, and G. This is the in order traversal of this tree. Now we have to see that how many nodes do not have a left child and how many nodes do not have a right child. First of all, I'm marking the left child. So H does not have a left child. I does not have a left child. E does not have a left child. F does not have a left child. J does not have a left child. C does not, C have a left child, which is F. G does not have a left child. Now, if we make it a normal two-way threaded binary tree, H would not be pointed. The left of H would not be pointed because in the in order traversal, H does not have any predecessor. Whereas I should point to D. So I'm making this. Okay. B should point to, okay, first let me just clear the pink line. So, all right. So now I'm marking again the left pointers which are null. All these are the left pointers which are null. So they should point to the predecessor. So I should point to D, and E should point to B, F should point to A, J should point to F, the left of J should point to F, the left of G should point to C. So we are doing these. Can you see? So this is actually a left threaded binary tree that we are creating right now, and the same way we will create the right threaded. Since H does not have a predecessor, so this will not point anywhere. This would be null right now. Okay, now let me take another color. Okay, the green color I'm taking. Now let's mark the empty right pointers. So this is empty. This does not have a right child. E does not have a right child. J does not have a right child, and G does not have a right child. So they should point to their successor in an order. Since G does not have any in order successor, so this should point to null. The right child of G should point to null. Now we talk about the J. J has C as the in order successor, and then E have A as the in order successor. I have B as the in order successor, and D has both left and right child, and H has D as the in order successor. So now those green threads will be completed. So H would point to D, I would point to B, and E would point to A, okay, and J would point to C. So this is a two-way threaded tree where the right threads are pointing with a green color and the left threads are pointed with the blue color. Can you see that? So this is an example of two-way threading. So this is the left threaded binary tree for the same. This is the right threaded binary tree for the same, and this is the two-way threading. Now, if we apply a header node to this, suppose we apply a header node to this. So this would be the header node. This would point to A. H would point to this header node, and this G would point to the header node, and header node would point to itself. So this is the way we can have a two-way threaded binary tree along with the header node. I hope you have understood what is threading. So kindly like, subscribe and share these videos, and subscribe my channel for more update on computer classes. Thank you so much.